So the concept that I want to talk about today are kinematic problems that don't necessarily have any, what do you call it? They don't give you a distance. So we'll be talking about a specific one. I'll read it out now. So a stone is dropped off a cliff. 10 seconds later, the person who dropped the stone hears it hit the ground. How tall is the cliff? Assume 330 meters per second for the velocity of sound. Okay, so immediately here we notice that we have all of our givens, 30 meters per second. Our initial velocity is going to be zero because it's being dropped and not thrown. So keep that in mind when you hear that in a problem. The initial velocity is going to be zero. Then we've got gravity, 9.8 meters per second squared, so cool. T equals 10 seconds. Now, don't confuse this as meaning that it takes 10 seconds for the rock to fall down. That would be a really easy problem to solve. Unfortunately, that's for the entire system to happen. It's taking 10 seconds for it to fall and then also for the sound to reach him. So, how do we set something like that up? Well, we would set it up as TF, so the time for the falling rock, plus TS, the time for the sound to reach the person, equals 10. So the entire system is 10, and I think that that follows pretty reasonably from the equation. So we have two kinematic equations that we're going to be using, which is, let's see, d equals velocity initial times time plus 1/2 acceleration t squared. And then we're going to be using also distance equals rate times time. Very elementary one. So along with this, we're going to have a system of three simultaneous equations. And it's not going to be that bad, don't worry. So, where do we start? We're going to start with the rock because we know we have acceleration, we have an initial velocity, and we kind of have a time. So our distance equals, well, our initial velocity is 0, so we just zero that out, plus 1/2 9.8 multiplied by time. And now remember, time is the time for the falling rock because that's what we're doing. So that time is going to be equal to 10 minus TS squared. Okay, so now we have the time and distance for the sound. So it's going to be the same distance because it's going the same distance. It's going the distance that the cliff is tall. So that's what we're solving for. Our velocity for sound we were given is 330. And our t is going to be ts because that's the time that we established for our sound. So, do you see what we can do here? These guys can get substituted. That was a terrible circle. But anyway, those can get substituted. And then we're left with an equation that's 330 TS equals 1/2 9.8 times 10 minus TS squared. Okay, so I'm going to go ahead and skip just a little bit ahead because I assume that you know the algebra behind all of this. So we're just going to use algebra to get a quadratic. So that's going to be 0 equals 100. Pardon me, I want to take a look at my sheet. Yeah, it's going to be 100 minus 87.35. TS. And that's going to be plus TS squared. So that's the quadratic that we get from this after we simplify everything. Okay, so we're going to write out our quadratic now, which is 87.35 plus or minus. And now the square root of everything we get inside is going to be, let's take a look. Okay. Yeah, so that's going to be, oh, 87.35 squared minus 400 over 2. So the discriminant that we get out of this is going to be, let's go up here a little bit. So we're going to have 87.35 plus or minus our discriminant of 85.03. I didn't use my calculator for that. Let me check that. Yeah, that looks right. Okay. That's correct. And put that over 2. That's going to be equal to TS. Okay, so one quick thing that you want to note here. If we add 87.35 plus 85.03 divided by 2, we're going to get a huge number for TS. And remember that TS plus T of F equals 10. So if we get a giant number for TS, then we're going to have a negative time for the falling rock. And yeah, I take in physics, negative time don't fly, so we're not going to do that. So instead, we're going to ignore the plus and focus just on that minus symbol right there. So real quick, I'm going to do the math on that. Looks like that would be... so that means that TS equals 1.16 seconds. And now wait, we have our formula. So 330 TS, which is going to be equal to 330 now, multiplied by 1.16. And now, if we do the multiplication, 1.16, freaking syntax errors. There we go, times 1.16. Yeah, there we go. So that's going to be, our distance equals 383 meters. And I hope that that makes sense from where we started, because we used our sound equation to travel that same distance that our falling stone would have traveled. So we don't even need to know our TF in order to solve for this. But if you want to check your answer, you could definitely plug that in there. So I hope you found this helpful.